So a very good day. It's very pleasure or honor for me to participate in this IEEE 5MFYP competitions. So let me introduce myself. My name is Md Jan. So I'm a student of Mechanical Engineering Technology, major in automotive. So my FYP project title is CFD analysis on the aerodynamics of small size car vehicles under the influence of steady crosswind. So have you come across about what is CFD? So basically CFD is defined as a set of numerical methods that have been applied to obtain the approximate solution to the problem of heat transfer and fluid dynamics. So in simple, the CFD, computational fluid dynamics, is the combination of three elements. First, engineering. Second, computer science. Third, mathematics. Basically, they are interconnected with each other and that cannot be worked independently. Besides, CFD actually has many types of software where it includes of OpenFlow, ANSYS Fluent, SimScale, or PowerFlow. So the software that have been applied to uh, do my research on my FYP is the ANSYS Fluent Flow. So since my project had touched about the small size car vehicles, so as an acknowledgement, my project, FYP project, the vehicle that involved is vehicle in segment A, which is a small size car vehicle. So vehicle size vehicle, they have different types. So we have segment A, B, C, D, E, F, and well, some luxury segment or even the performance segment cars. So my focus or my scope will be focused on the small size car vehicle, which is a segment A. On the other hand, let me introduce you what is the situation without the crosswind first. So without the crosswind, the wind, just imagine a vehicle is travel on its path. So the wind that involved that without the influence of crosswind is the headwind and the tailwind. So the idea of crosswinds comes in where it will either affect on the from the left side of the vehicle or the right side of the vehicle. So for example, if the crosswind is come from the right side of the vehicle, when it hits the vehicles, eventually it will cause the vehicles to be deviated and it will cause the crosswind yaw angle. So the minimum of the crosswind yaw angle is 0 degree, which is not in the no crosswind, and the maximum is the 90-degree crosswind yaw angle. Besides, when the vehicle is travel on one direction, eventually there will three force will be effect the vehicle under the influence of the crosswind. First is the direction that opposed to the vehicle that we're traveling, which is known as the drag force. Second is the crosswind, which is known as the side force. And lastly, it will give a floating effect, which is known as the lift force. So through this analysis, ANSYS software eventually it will help us to analyze the aerodynamic loads, which were have been mentioned just now, which is the drag force, side force, and the lift force. So besides, it will help us to give a picture on the how's the flow behavior of the vehicle with respect to different of crosswind yaw angle. For example, we will analyze the velocity streamline behavior with a different type of crosswind yaw angle. We will check the leeward and the windward. The leeward is the wind far away from the which is known as the crosswind outlet, and the windward is the crosswind inlet. And we will also check how is the behavior, the pressure that projected on the vehicle. So eventually, when there is a red color, eventually it tells us that there is a high pressure there. So eventually it tells us that uh, because since it's according to the Bernoulli principle, that's why we know when there is a high pressure, eventually we know there is a low velocity. So lastly, we also help us to analyze what is the pressure contour or the velocity contour to this analysis, to this ANSYS software. So that's all for me. Thank you.